Welcome to the Midland Learning Channel. We are so excited to introduce to you a new revision series for Physics Advanced Level, Paper 2. We are going to be taking equation daily by the grace of God. So we are going to start right away with June 2001, Paper 2, GC Advanced Level Physics, Question 1. The question reads, a 100-gram calorimeter contains 300 grams of water at room temperature. 50 grams of ice is added to this calorimeter and the equilibrium temperature recorded is 282.7 Kelvin. Calculate the room temperature given that the specific heat capacity of copper is 380 joules per kilogram per Kelvin and the specific latent heat of fusion of ice is 3.25 times 10 to the power 5 joules per Kelvin. I'm going to introduce you to a proposed solution. The first thing I want you to take note of is how to come up with the energy equation. You need to ask yourself, where is the heat moving from? Where is it going to? In this case, we'll see that the heat is leaving from the calorimeter plus the water inside the calorimeter, and the heat is going to the ice to melt, and after melting, the ice that has melted is going to continue gaining heat in order to increase its temperature. So we have the energy equation: heat lost by the calorimeter plus water equals the heat gained by ice to change the state plus the heat used in warming the melted ice. If this is understood, we can translate into a mathematical expression or equation. Here, the heat lost by the calorimeter is given as the mass of the calorimeter, specific capacity of the calorimeter. Now, theta R is the room temperature, which is the initial temperature of the calorimeter and the water. And from the equation, we'll see that this temperature is higher than the equilibrium temperature, 282.7 Kelvin. That is given. That's theta, 282.7 Kelvin. What does this mean? It means the calorimeter is going to lose heat and the temperature will drop from that room temperature that we don't know, theta R, to the equilibrium temperature that is given, 282.7 Kelvin, and here is indicated as theta. For the water inside the calorimeter, the same thing happens. It loses heat and the temperature drops from the equilibrium temperature, from the room temperature theta R to the equilibrium temperature theta. So we are looking for the room temperature theta R. Now on the right hand side, you look at the ice. For the ice, when it's changing state, the temperature does not change. That's why we have here mass of ice, latent heat of fusion of ice. When all the ice must have melted, the next thing is that the liquid start gaining heat to increase the temperature. Now remember, when it is melting, the temperature is 0 degrees Celsius, which is 273 Kelvin. So you can see the 273 Kelvin here. So after melting, it gains heat and the temperature increases from 273 Kelvin to the new equilibrium temperature 282.7 Kelvin. So you can see here, this 273 Kelvin actually is 0 degrees Celsius, which is a temperature when it's melting, and when it gains heat, it increases now to the equilibrium temperature theta. So from this mathematical equation, we just need to arrange it, then we make theta R the subject and solve it. We are going to get the answer 296.8 Kelvin. Let me know what you think about this question. Try it, make R the subject of the formula and leave your comment. Please don't forget to subscribe to our channel if you want to continue receiving videos from us. Thank you so much.